In this video, we're going to be looking at more solutions for the review for exam 2. Starting with problem 31, it says a jar contains 3 red, 4 blue, and 5 white marbles. A marble is drawn and its color is recorded. The marble is not put back in the jar before the second marble is drawn. Is drawing marbles in this manner independent events or not? And the answer would be it is not, because independent events are events whose probability does not have an effect on one another. But in this case, when you draw the first marble, if you don't replace it, you are changing the probability of the draw for the second marble. So our answer here is that it's not independent, because drawing one marble and not replacing it affects the probability of the second marble. Let's go on to question 32. 32 says, a police officer watching a particular stretch of highway in Montana finds that about 1 out of every 5 drivers is speeding. What is the probability that at least one of the next 8 drivers he sees is speeding? Okay, if it says at least one, the way we do these problems is the probability of an event occurring, let's say event, at least once, is going to be the same as 1 minus the probability of the event not occurring. Now, if the probability that someone is speeding is 1 out of every 5, we're going to write that here. Probability of speeding is 1 out of 5. So the probability of at least one of the next cars in the 8 cars he sees speeding, we have to do this way. So this would be the same as 1 minus no cars speeding. Nobody speeding. Now here we defined the probability of a car speeding as being 1/5. That means the probability of a car not speeding is 4/5, because it's the complement, which would be everything else. If 1/5 is speeding, then 4 out of 5 is not speeding. So the probability of nobody speeding in the next 8 cars is going to be 1 minus 4/5 to the 8th. Let's calculate that. We can see here on Desmos that 1 minus 4/5 to the 8th is 0.832. Now we can write it that way as a fraction, or we can press here and it will reduce the fraction. But it didn't reduce it very well, so I'm going to just leave it as a decimal, 0.832. When we write a decimal, we're going to round to the 3rd decimal place. In this case, there's a 2 behind that decimal, so we're going to say this is 0.832. Problem 33 says an instructor expects 10% of the class to earn an A on the final exam. If there are 23 students in class, what is the probability that at least one student earns an A on the final exam? So similarly, the probability of at least one A is going to be 1 minus the probability of no A's. So if the probability of the A is 10%, then the probability, so let's write that, probability of an A is 10%. Then the probability of no A's, which I'm going to write like that, because that means the complement, is 0.90. So here we want to do 1 minus the 0.90 probability of no A's, but there are 23 students in class, so we're going to take this to the 23rd power. Let's see what we get. It looks like when we plug this into Desmos, we got 0.913. And then we're going to keep it, no, excuse me, we got 0.911. and we'll keep it as a 1 because the number behind it is a 3. So our answer on this one is 0.911. In question 34, it says a fair coin is tossed, then a fair die is rolled. What's the probability of getting a head and a number less than 3? I think the easiest way to do this problem is to write the sample space. So let's do that first. So here we have our sample space. You could get a head and on the coin, and then the numbers 1 through 6 on the dice, or a tail and the numbers 1 through 6. So what's the probability of getting a head and a number less than 3? So we're only looking at these, but our total, it's out of 12 because it says and. And the overlap for a head and numbers less than 3 would just be the head and a 1 and the head and a 2. So this is going to be 2 out of 12, which we can reduce to 1/6. Let's see if we can do this next one without drawing sample space. Although, when you do these, you certainly can look at the sample space of cards, which is in your section 3.1 notes, I think. So let's look at this one. 35 says a card is drawn from a well-shuffled deck. Its number is recorded, and then the card is returned to the deck. A second card is then drawn. What is the probability of getting a jack on the first and a spade on the second? So we learned in our notes that the probability of one event and, because it says and, another event, A and B, is going to be the probability of A times the probability of B. So here, the probability of getting a jack, there are 4 jacks out of 52. And a spade, there are 13 spades out of the total deck of 32. So we're going to multiply that by 13 out of 52. Let's see what that gets. Multiplying these together, we get 0.019. You'd round it to the first 3 decimal places. In this case, it's a 2 behind the 9, so we keep it as 0.019. If we wanted to reduce that fraction, it would be 1 over 52. So let's write that. Of course, when we write it as a decimal, that is an approximation. So on Desma or Derivata, the homework, they usually want it as a fraction. Let's go on to question 39. Question 39 says a researcher surveys 150 youth or young athletes asking about the last sport the athlete played and whether or not the athlete was injured playing that sport. The data is summarized in the following table. So here are our sports, injured, not injured. If you add them up, you can see a total of 50 people played gymnastics. And for not injured, a total of 95 of the 150 were not injured. Let's see if we can answer question A. If an athlete is picked at random, what's the probability that the athlete played soccer and was not injured? So again, and is the overlap. So here's our soccer row, and not injured is right here. Soccer row, not injured column, that's going to be 30 out of 150. Which of course reduces to 1/5. And then did gymnastics and was injured. So again, it's going to be the overlap because it asked for and. So gymnastics is up here, and we want to know how many of those were injured. So that's going to be the 16 out of 150. And that's going to reduce to 4 out of 75. Now, played football or was injured. Now, our formula for an or problem is to go the probability. In this case, it would be the probability that they were football or injured. Our formula for ors, for an or problem, is to go the probability of the first plus the probability of the second minus the probability of the overlap, which is P and B. So minus football and injured. Okay, so let's go up here. The total for football is 45. So this would be 45 out of the 150. The total for injured, that would be this row or this column, is 55 out of 150. But in taking that total, we counted this 27 twice because the 27 is counted, 27 plus 18 is 45, and 27 plus all of these numbers is 55. So we have to subtract out the and, football and injured. So we're going to subtract out 27 over 150. So this is going to give us 100 minus 27 is 73 over 150, and I don't think that can be reduced. All right, let's go down to our next question here, 40. Suppose you draw two cards from a standard deck of cards without replacement. What is the probability that you get an ace on the first and a 7 on the second? So we know that when it says and you're given it in this form, you're going to multiply the probabilities together. So the probability that you draw an ace is going to be, let's see, there are 4 aces out of 52. And the probability that you draw a 7 is also 4 out of 52. When you multiply this, you're going to get 16 over some number. Nope. Sorry. 2704. Which is going to reduce to 1 over 169. And you can write that as a decimal if you wish. Question B asks, you draw a heart and a spade. So the probability of a heart is 1/4 because 4 of the suits, you have 4 suits total and 1 suit is heart. And a spade also is 1/4. Oh, wait, you know what? I screwed these up. These are both wrong. One thing I didn't pay attention to is that you're not replacing the card once you do this. Oh my goodness. So if we go back to our previous problem up here and we look at not replacing. So they're going to draw the ace and they're going to keep the ace out. So the chances of drawing the 7 here are going to be 4 out of 51 because there are now only 51 cards out of 52 total cards. So if we multiply 52 times 51, no, we get 2652 in the denominator. All right, so sorry about that. I was thinking it was with replacement. So 2652. Let's see if that reduces. We can do that on Desmos. So we have 16 divided by 2652. And that's 0.006 or 4 out of 663. 0.006. All right, now let's look at this second one. We'll do the second one in black. You draw a heart and a spade. So the probability of a heart is 13 out of 52, which is 1/4. But now the probability of spade is there are still 13 spades, but there are only 51 cards left in the deck. So this is going to be 169 over 2652. which might reduce. I think it does. It's point, okay, so if we look at this on Desmos, when I did 169 divided by 2652, we got 0.063, but the number behind it is a 7. So we're going to round this to 0.064 or 13 over 204. It's right there. Now let's look at part C. You can draw 8 on the first card and a face card on the second. So this is kind of back to the same old thing. And 8 on the first card, there are 4 8s out of 52 total cards. And so we're multiplying a face card. There are 12 face cards, but that now it'll be out of 51 because we removed one of our cards. We multiply this together, we get 48 over 2652, and that will reduce to 4 out of 221, which is about equal to 0.018. All right. Oh, let's also hit part D on this one. You draw 2 hearts in a row. So the first heart, there are 13 hearts out of 52. And the second heart, now there's only 12 out of 51 because you took one of the hearts out and you removed a card from the deck, so the denominator is 51. If we multiply these together once again in our denominator, we're going to get 2652 and 13 times 12. 156. And that reduces to 1/17 or 0.059. Yep. All right, in our next video, we will pick it up at problem 41. Thanks for watching.